let's now take a look at this idea of propositional logic. So we're going to start by understanding the difference between a simple and a compound proposition. When we say proposition, we just mean any declarative sentence that can be either true or false, or one that a declarative sentence asserts to be true or false. So it's similar to a sentence, except specifically it has to be some statement that can be shown to be true or false. If we look at example 1, trying to determine whether each sentence is a proposition, part A says Florida is a state in the United States. Well, that is a statement that can be determined to be true or false. In this case, it's true, so that would be a proposition. But in B, the question, how are you, is a question, so it can't be a proposition. C, humans cause climate change. That is a statement that can be shown to be true or false, so here it would be a proposition. 1001 is a prime number, is a statement that can be shown to be true or false, so that would be a proposition. For E, run for cover, that is a command, so that cannot be a proposition. And then the statement, this sentence is false, is not a proposition because it can't be true or false. If the statement is true, then it says the sentence is false. And that's a conflict. So the problem with this particular sentence is that there's just no way for it to be true or false. Now, a simple statement is a statement that's just going to convey a single idea, but a compound statement would have two or more ideas. Some of the standard symbols that we'll use if we wanted to say not P, so some statement P, and we wanted the negation of it, the word that we would use here, the connective, would be not, and the symbol we would use is that little squiggle, the tilde on our keyboard. So that implies that we're looking at a negation, or the opposite. P and Q, that's our conjunction. We use the word and to combine our two statements, and we use the little symbol that's an up arrow in symbols to show that we're doing the statement P and Q. If you wanted an or statement, P or Q, you use the word or, and we call that a disjunction. The symbol here is the arrow part pointing down. And then we also will have these conditional statements. If P, then Q. You'll use if and then to connect them, and the symbol you'll use is P and then the arrow to the right, Q, to show that P implies Q. In example 4, we can look at these 4 statements. The statement P, the game will be played in Atlanta. Q, the game will be shown on CBS. R, the game will not be shown on ESPN. And S, the Mets are favored to win. If we wanted to write these in words, A would be P and S. So we would say the game will be played in Atlanta and the Mets are favored to win. B means not R or Q. So we need to negate R. The game will not be shown on ESPN. The negation is the game will be shown on ESPN. Then we say or Q. So our statement here would be the game will be shown on ESPN or the game will be shown on CBS. And then the last one, P implies not Q. Let's first negate Q. That would say the game will not be shown on CBS. So here our statement is if the game will be played in Atlanta, then the game will not be shown on CBS. We're going to organize our propositions using a truth table. So first, we're going to identify the truth value of a simple statement. It is either true or false. Remember, a proposition has to be able to be either true or false. Now, the truth value of a compound statement is going to depend on some rules and the type of connective that's being used. So we'll look at some of the truth values for some of these compound statements here in just a minute. A truth table is going to put all of the possible truth value of these compound statements using all possible truth values of the individual simple statements. So we'll put this all together so you get an idea of how this works. So for example, if we're looking at a negation, our truth table would look like this. For any proposition P, the proposition can be either true or false. If the original proposition is true, then the negation would have to be false, because the opposite statement of a true statement would be a false statement. Now the next line, if our proposition was false to begin with, then our negation would be true, because we're looking at the opposite of a false statement, which would be true. If you have a double negative, so the negation of a negation, you would use two tildes, and that would just go back to the original statement. Now when you have two statements, they could either both be true, the first one could be true and the second one could be false, the first could be false, the second could be true, or they could be both false. When we look at how that plays out with two statements, an AND statement is only true when both of the simple statements are true to begin with. So if you have a true statement and a true statement, the conjunction will be true. But when you have a true statement and a false statement, the conjunction is false. One true, but also one false. Overall, the conjunction is false. Think about this. If you say a statement 1 and a statement 2, the only way you can be telling the truth is if both of those were true. So if you had a false and a true statement, that's false. And if you have two false statements, that's also going to be false. Another way you can think of this is if you order cake and ice cream, the waiter is going to bring both. So this slide just summarizes that the conjunction P and Q is only true when both P and Q are both true. Otherwise, it's false. Now we can look at the disjunction, the OR statement, and here OR statements will be true as long as one of the statements to begin with was true. If you say something or something, you only need one of them to be true for you to be saying a true statement. If they're both true, that's even better, but it's still a true or statement. So true or true is true. True or false would overall be true. False or true would be overall true. But two false statements would be false, because if you say something that's false or something else that's false, you haven't said anything true, so your or statement would be false. So here, this summarizes the disjunction. P or Q is true as long as one of them is true. Otherwise, you have false. And then we'll have equivalent statements when the truth values of two statements are exactly the same. So we're going to use our truth tables to determine if statements are equivalent. If they are equivalent, we'll use the 3 equal sign to show that they're not the same, but they are equivalent based on their truth values.